Thank you all for joining us. Here we are on our part 3 of Autodesk simulation webinar series. My name is Dan Montano. I'm an application specialist with SolidCAD. My colleague Robert Piccinich, the industry account executive for manufacturing, couldn't make it this presentation, but he sends you his regards. So let's get going. Today we're going to be talking about designing and optimizing with Autodesk Nastran-in-CAD. A couple of slides about our company for those of you who are social media inclined. Here are some handles. I'm told they're called. You know what to do with them, and if you want to stay in touch, you can find us here. SolidCAD, it's a company that started 28 years ago as a Autodesk partner. It's the first Canadian Autodesk Platinum partner, and currently has the largest team of application specialists in Ontario. And as of August 1st, 2015, it merged with Council's Ontario Autodesk Business Unit. And this allows us to basically serve our customers better and exposes our clients to a broader range of customer professional services and product expertise. SolidCAD is also a authorized training center and a certification center for these disciplines, AEC, product design and manufacturing, process and power, and civil infrastructure. And we try to stay on top of newest technologies, adopt them, test them, and offer them to our customers. Some of our strategies here in terms of serving our customers, focusing on the process of aligning technical workflow with business objectives, industry-specific teams and targeted solutions, offering recommendations based on best practices in the industry, and offering top-level expertise and customer successes. And you can find us at these email and phone numbers for our technical support services through what we call Solid Assist. Technical support from our team of experts. Some of the services SolidCAD offers, we're offering consulting services and implementation of building information modeling strategies, design process and workflow assessment, data management, product lifecycle management, customization and software development, simulation and analysis, and reality capture using 3D laser scanning, as well as mentoring, assigning, assisting design and production teams, and offering help with technical and project-related issues, challenges, and questions. So, in today's agenda, back on our Nastran-in-CAD discussion here, I'd like to give you a brief introduction to the current Autodesk simulation portfolio. Go through the benefits of finite element analysis briefly, and spend some more time on Nastran-in-CAD. What is it and how it can help you? And if time allows us, we're going to go through some customer successes implementing Nastran. Currently, Autodesk simulation portfolio is comprised of a large number of tools covering different types of analysis and different industries, structural mechanics, structural architecture, flow and thermal analysis, molding processes, composites. Nastran-in-CAD is the current flagship on the structural mechanics side. Autodesk Robot Structure Analysis Professional on the structural architecture, the Autodesk CFD and Autodesk Flow Design on flow and thermal analysis, Autodesk Mold Flow Suite on molding processes, and Autodesk Helios PFA and composite on high-end analysis of composites. This is a result of long-term strategy. In the last 10-12 years, Autodesk invested over $400 million in simulation tools. On the mechanical simulation side, there are basically currently two products which would require your attention. One is the Nastran-in-CAD, which is a CAD-Embedded Advanced Mechanical Simulation that we're going to be talking about today. This uses the Nastran solver, which is also available on other pre- and post-processor. And the Fusion 360 Ultimate, which is the cloud-based 3D CAD/CAM CAE platform that uses Nastran for parallel cloud solving. Some of the benefits of finite element analysis, first and foremost, reducing the number of physical prototypes with huge cost reductions, improving time to market, allowing for material testing, increased product functionality, and being able to better product performance. In terms of where simulation fits in the design process, ideally we should be able to use simulation early in the design and engineering phase, where the ability to affect functional capabilities is highest. Traditionally, this is done after part fails with increased costs and complications. Let's see a couple more things about Nastran-in-CAD, a little bit more in detail. So it is a general purpose finite element analysis tool currently embedded on top of two CAD platforms, Autodesk Inventor and SolidWorks. And some of the benefits of Nastran-in-CAD: CAD-embedded analysis, advanced simulation capabilities, and using the accurate and trusted Autodesk Nastran solver. In terms of some comparisons between Nastran-in-CAD and the Fusion 360 Ultimate, these are some of the capabilities of Nastran-in-CAD, which as of mid-2017 have not been implemented yet in Fusion 360 Ultimate. Shock and vibration, event simulation through a small control movement, nonlinear transient, CFD integration, composite materials, and rubbers and elastomers, fatigue, and different idealization types. And here are some of the abilities or capabilities of Fusion 360 Ultimate. It is a cloud solving tool, allows us to take advantage of parallel computing in the cloud, as well as for some analysis, local solving. It allows us to reduce mass of a part using topology optimization. And in terms of event simulation, it can deal with large uncontrolled motion in this nonlinear transient solution implemented using an explicit solver. In terms of let's say similarities, more than differences between Nastran-in-CAD and Simulation Mechanical, which is a product on the way to retire to Autodesk. You can see from this table that most linear structural capabilities and nonlinear structural capabilities are covered by the Nastran-in-CAD. So for those of you who currently use Simulation Mechanical, especially with the Nastran solvers, it should be a smooth transition. Some of the questions that Nastran-in-CAD could answer. Will my design fail? Or could it be optimized? Can I make it lighter? Can I try maybe different materials? Can I come with a working solution within the design restrictions so I can get to market sooner? Now let's see how we do some of these things. For example, in terms of failure analysis, we can look at fatigue over the product's life, figure out how the consequences of vibration affect our design. Look at nonlinear deformation and failure modes. Look at the effects of thermal loading, temperature distributions, thermal stress. Could my design be optimized? We could try different materials, reduce number of components, vary the shape of components to get to an optimum design, reduce the mass of components, part thickness, improve component quality in general. How can we get to market sooner? By reducing the number of physical prototypes, upfront material testing, try more options, more design variants, maybe for discovering unseen design opportunities to improve the model, the functioning of our parts and assemblies. Understand how to simplify designs safely. As I'm sure it's well understood, product design does have an impact across the whole organization, from sales to marketing to finance to legal, manufacturing, engineering, customers, and suppliers. So being able to optimize our designs will have long and wide consequences across the whole company. Let's look at some Nastran-in-CAD features. And I was mentioning earlier CAD-Embedded tool, and here are some of the benefits. So using a CAE, an FEA tool inside your familiar CAD environment that you use daily for design exposes you to similar interface and workflow. No need for CAD model translations, importing, exporting files, healing geometry, and so on. The model could be updated on the CAD environment and basically opened as is with new modifications on the FEA side. So we provide true model associativity at this point, and ease of use is an important goal here for both Autodesk Inventor and SolidWorks users. On this note, let's take a look at a short video here. We have a model of a frame set up in Inventor using a frame generator. And on top there is a thin part, let's say a sheet metal part or a plate welded on the frame. From a linear static point, structural verification could be done in Inventor frame analysis, but that would exclude totally the thin model on top. You can see here, just by moving into the Nastran-in-CAD environment, automatic discretization of the frame generated models has been done to beams. So the cross-section properties are extracted automatically. Then we can do a mid-surface model to shell elements of the thin model on top. And then we can do a manual contact generation between the top frame members and the plate using offset bonded type contact. So even though we do have a distance there, a gap, we can generate that contact and provide for the proper load path. Here's the meshing based on beam element sizing prescribed there, and a quick run on a linear static analysis based on actually in this case just the self-load. Here's the stress contour on the shell plate as well as the stress contour on the beams. So quick generation of or extraction, the creation of the finite element model from the CAD model, associativity here ensured by just going back to the assembly and modifying it, changing the let's say the frame members, going back into the Nastran and updating the analysis. Another characteristic here of Nastran-in-CAD that could be useful is the fact that Nastran-in-CAD comes as a network license. So you could have the flexibility of floating a license across multiple CAD users and share it this way in your CAD environment for both Inventor and SolidWorks users. Here's a video showing the Nastran-in-CAD in the SolidWorks interface. There's a stress contour plot of a nonlinear static analysis where results post-yield are shown here on a section model. So a large set of tools for post-processing, generating the proper reports and the proper visualization results needed. And not last, the fact that it's using the Nastran solver, which is proven and credible, verified with NAFEMS benchmarks. I'm sure you've heard of this organization. And over 5,000 plus test problems per release, for each release, using advanced analysis techniques, nonlinear, dynamics, composites, scalable, and high-end simulation technology. I mentioned a wide range of analysis capabilities, including nonlinear materials, large deformations, and being able to choose the proper one, even from the get-go. It's important to get the accurate results. Here are some of the basic analysis capabilities in terms of linear statics, buckling, modal, pre-stress, normal modes, linear steady-state heat transfer, composites, assembly modeling with contact, thermal stress, and some of the advanced analysis capabilities in terms of nonlinear static, nonlinear transient heat transfer, nonlinear steady-state heat transfer, random response, frequency response, response spectrum, linear and nonlinear transient response, advanced nonlinear and hyperelastic materials, drop test, and impact analysis. Connection with Autodesk CFD is also possible. We can bring in the results from Autodesk CFD to use as loads, the temperature and pressure profiles. We'll map those to structural mesh as external surface pressure and entire solid temperature, and we solve that in the structural analysis. Here's a demonstration of this workflow. Autodesk CFD tool with, where we have a model of a pipe elbow with fluid flowing through it at a certain temperature, and then we can bring this into Nastran-in-CAD, suppress 3D CAD models that are not needed, like the air and the poppet here, and load results, temperature results at whatever time moment from the CFD analysis. As a consequence of this thermal stress, you can visualize the stress profiles here based on the thermal loads. So I mentioned heat transfer analysis, so we do cover steady state and transient, both linear and nonlinear. So temperature dependent convection coefficient, conductivity, emissivity, as well as on the nonlinear side, time dependent temperature and heat flux. Another capability of the tool, fatigue analysis, both multi-axial fatigue, where a linear static stress analysis will run first. Different loads appropriate for static stress analysis could be applied, and each load could then be assigned a load history, time dependent, as well as vibration fatigue. So this time a random vibration analysis based on power spectral density load is generated. Both SN and EN life could be studied. In terms of linear dynamic analysis, we do cover frequency response, transient response spectrum, both based on natural frequency. The frequency response analysis as well as the transient analysis could be investigated from both direct and modal perspectives. A quick video here of a response spectrum, or simple building model with beams and shelves, and the different analysis types for shock and response spectrum. Okay, so we can set lower frequency bounds, weight, mass, scaling factor, summation options. We have the opportunity to assign damping properties based on different tables. Here's a frequency versus response spectrum table, and the XY plot, assigning the response spectrum as a boundary condition, and running the analysis. Oh, here's a connector on the bottom there for an external mass. Okay. And here are some success stories, different companies around the world that have successfully implemented Nastran-in-CAD and take full advantage of its capabilities. Mentor Services, Cessna, Niner Bikes, Smith & Engineering, STX Canada, Wilson, Eyring & Associates. So, for example, Mentor, a manufacturer of equipment for aggregate and asphalt industries, needed to bring some of the FEA work in-house, reduce the work of parts that are oversized or failing, and ensure compliance with government oil customer standards. Why Nastran? First and foremost, embedded solution with Autodesk Inventor. Consistent look and feel, and the ability to idealize geometry for bolted connection. In terms of results, more effective overall workflow with the embedded products. Quickly finish several products in less time due to less physical testing. Cessna, well-known manufacturer of aircraft. Typical challenges like reducing mass of components to improve fuel consumption, reducing analysis cycle time. Chose Nastran, Autodesk Nastran for some of the advanced element modeling capabilities like tension-only quads, complete access to legacy data, superior technical support, and users will be able to eliminate some of the redundant models, repetitive work functions, and reduce analysis time with model idealization. Is a minor manufacturer of high-end bicycle frames, needing to optimize the stiffness and ride characteristics of the bike and minimize the weight of frame and wheels. Based on the proven history and versatility of Autodesk Nastran and the ability to write custom applications to take advantage of the application programming interface or API and automate some of the simulation tasks. They chose this tool to have the ability to improve the optimized stiffness of the frame and reduce the weight. Smith & Engineering. Here's an example of using topology optimization to reduce the weight of aircraft cabin brackets and test different materials for cost savings and mass reduction. Being able to use advanced nonlinear and composite materials was important in Autodesk Nastran choice, and being able to easily analyze various design setups with minimal rework. As a result, mass was reduced by 50% using a new design and different materials with cost savings of $400,000 on 200 sets of brackets. STX Marine, a consultant for vessel design, needed to minimize the size of the structure, reduce design time, and improve the part capabilities there. Nastran was chosen because of easy analysis of thin wall structures and stress and buckling analysis without rework, and that allows to minimize the size of the crane structure and significantly reduce structure size and provide savings on manufacturing cost and time. And lastly, Wilson Erring and Associates, consultant on acoustics and noise and vibration control, required optimization of a design of an automated people mover, a major airport, and ensure that this movement does not disturb travelers. Chose Autodesk Nastran based on the benchmark analysis work that matched previous testing results. and determined that vibration isolation was required for a new structure and avoided costly mistakes in manufacturing and design early with upfront analysis. That's about it for today. I just wanted to point out the simhub.autodesk.com, the Autodesk simulation hub here, where you can have access to forums, SimTV, blogs, and basically stay on top of developments. Thank you very much, and we'll come back with a series of more detailed webinars detailing specific functionality for Nastran and in CAD and CFD. Thank you.